Hi everyone, today we'll look at Spark. Spark is a popular distributed computing framework that many people call Hadoop 2.0. It is in fact not a modified version of Hadoop, but it was created to address some limitations of Hadoop. Spark is a fast, MapReduce-like engine that speeds up computation by storing data in distributed memory across multiple machines. And because of that, a Spark program could get a great speed boost over Hadoop MapReduce, which is disk-based. Spark itself does not come with a backing distributed storage system, so it depends on other existing systems, such as Hadoop and HBase. When we talk about Hadoop, usually we would use the term Hadoop ecosystem, because Hadoop is in fact a collection of many technologies, and also because many technologies have been built on top of Hadoop, such as Pig, Hive, and HBase. For Spark, we have something similar. Spark SQL is a component of Spark ported from Hive, so it's compatible with Hive data and Hive's query language. Spark SQL enjoys great speed boost over Hadoop, thanks to Spark's ability to store data in distributed memory. The Spark project started in 2009 at UC Berkeley and was open sourced in 2010. It became a top-level Apache open source project in 2014. This is great because that means it's here to stay. Most top-level Apache projects have extremely strong community support from industry and academia. Spark is built by over 1,000 developers and people from over 200 companies and organizations, such as Amazon, eBay, IBM, NASA, and Yahoo. Spark is now used in large computing clusters with over 1,000 nodes. A main reason behind the creation of Spark was due to Hadoop MapReduce not being able to efficiently handle iterative computation typically needed in machine learning and graph algorithms. So Spark was created to speed up data sharing, and specifically by storing data across distributed memory. One misconception that many people have is that they think MapReduce is dead, especially after they have read articles that suggest Google has dumped MapReduce. This is not true for multiple reasons. First, MapReduce is a programming model. Many higher-level technologies are actually built on top of it. For example, a Pig program or Hive program are converted into MapReduce programs. Another reason is that it takes time to completely phase out technology that has been in place for years. So while it may very well be that Google wants to eventually use more of some of their newer technologies, it's going to take some time. To easily refute articles that wrongly claim Google has dumped MapReduce, a Google employee said on Reddit that he was just running some MapReduce jobs a few weeks ago, before the article appeared. Now let's take a closer look at how Spark speeds up computation. First, let's consider what happens in the case of Hadoop MapReduce. Let's say we want to run a machine learning algorithm that uses gradient descent, which is iterative computation. Since Hadoop is disk-based, in the beginning of each iteration, the program would need to first load the data from disk, do the computation, and then at the end of the iteration, write the results back to disk. And this happens for every iteration. So that means there's a lot of disk I/O, reading from disk at the beginning of iterations and writing to disk at the end of iterations. Now let's consider another scenario where we want to do some queries on a large data set. Let's say the first query tries to find a subset of data that contains a particular word, and the second query is almost identical to the first query, except that it tries to find a different word. If these two queries are implemented as conventional Hadoop MapReduce programs, the two queries will need to read the full data set from disk twice. The first read for the first query, and the second read for the second query. Needless to say, this is very expensive. Now, if we use Spark, we can cut down the computation time dramatically by keeping the data that needs to be iterated through many times in distributed memory. That is, for machine learning algorithms that involve many iterations of computation through the data, we can keep the data and intermediate results in memory, as shown at the top of the screen, instead of pushing them to disk. Similarly, for the query scenario, we can first load our data set into distributed memory, and then run our queries against this in-memory data. This saves us from having to reload the data from disk for future queries. So not surprisingly, Spark can be quite a lot faster than Hadoop MapReduce, since memory I/O is much faster than disk I/O. So how does Spark keep data in memory? Internally, Spark uses a data structure called RDD, short for resilient distributed datasets, to let users explicitly persist intermediate results in memory across multiple computer nodes, and to manipulate them using parallel operators that can process these in-memory data. To provide fault tolerance, these RDDs can be automatically rebuilt if a machine dies. Spark now supports several programming languages, including Scala, Java, Python, and R. Spark can also be used interactively from a command prompt. In this video, we saw an overview of Spark. Look at the main benefit of Spark in that it can store data in distributed memory to avoid disk I/O. We also briefly described RDDs, Spark's underlying data structure that enables this.